Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P2135, indicates an incorrect voltage correlation between the throttle position, TP sensor A, and sensor B. This situation arises when the signals from these two sensors diverge beyond acceptable limits, affecting the vehicle's engine performance and throttle control. The TP sensors play a crucial role in determining the position of the throttle body, which in turn influences engine power and efficiency. They are usually located on the throttle body itself, which is situated between the air intake and the intake manifold in the engine bay. When functioning properly, these sensors send voltage signals to the Powertrain Control Module, or PCM, which processes the information to adjust fuel delivery and ignition timing. If the voltage readings are erratic or incorrect, the PCM may trigger a limp mode or reduced power to prevent potential engine damage. The throttle position sensors A and B are critical components that work in tandem to gauge the throttle opening angle. They provide real-time data to the PCM, which adjusts the air-fuel mixture accordingly for optimal engine performance. These sensors are located on the throttle body, a component that regulates the airflow into the engine. When there is a discrepancy in the voltage readings from these sensors, as indicated by DTC P2135, the PCM recognizes this as a problem. This error can lead to issues such as poor acceleration or stalling. The vehicle's onboard diagnostic system is designed to monitor the readings constantly and identify when the signals from the sensors are not in sync. Prompt identification and rectification of this error is crucial for maintaining optimal engine function. Several factors may lead to the activation of DTC P2135. Firstly, a faulty throttle position sensor A or B can send inaccurate voltage signals, triggering this code. These sensors may degrade over time due to exposure to heat or contaminants. Secondly, wiring issues, such as short circuits or damaged wires leading to the sensors, can disrupt the communication between the sensors and the PCM. Lastly, the PCM itself may malfunction, processing incorrect signals from the sensors, which could also lead to this DTC being triggered. Identifying the root cause is essential to effectively resolve the issue and ensure reliable vehicle operation. Each of these potential causes requires thorough testing to determine the specific origin of the problem. The symptoms of DTC P2135 can vary, but often include a check engine light illuminating on the dashboard. This is typically the first indication that a fault exists within the vehicle's electronic systems. Drivers may also experience poor acceleration, meaning the vehicle may not respond adequately when the accelerator pedal is pressed. This lack of responsiveness can create dangerous situations, especially in traffic. Engine stalling is another severe symptom, where the engine may turn off unexpectedly, leading potentially to a loss of control. It is crucial to address these symptoms promptly to restore the vehicle's overall performance and safety. Ignoring these issues may lead to further complications and increase repair costs. The first step in troubleshooting DTC P2135 is to verify the problem by initializing the vehicle's on mode. This involves turning the ignition to the on position without starting the engine. After this, using the Honda Diagnostic System, HDS, clear the DTC to reset all diagnostic codes. It is vital to monitor any stored error codes during this process, as the HDS will allow you to check for any pending or confirmed DTCs related to the issue. If DTC P2135 is indicated again, it confirms that the failure has been repeated and requires further investigation. If it is not indicated, this could point to an intermittent failure, emphasizing the importance of checking connections or terminals for wear or looseness to ensure reliable signal transmission. In the second step, the focus shifts to determining the potential failure area by checking the Powertrain Control Module, PCM, and related components. Begin by turning the vehicle back to the off position and then using the HDS to jump the SCS, Service Check Signal line, waiting for more than a minute. This process ensures that the system is reset. Next, disconnect the PCM connector B, specifically the 51P type. At this point, testing for continuity between specific terminal points is necessary. Test point 1 is typically at PCM connector B, pin 31, while test point 2 is at pin 40. Establishing if continuity exists here will determine the next course of action. If continuity is confirmed, it propels the investigation to the next troubleshooting step. Step 3 involves checking for possible wire shorts between the THL1 Throttle Position Sensor A line and the THL2 Throttle Position Sensor B line. Initially, disconnect the throttle body 6P connector to prevent feedback while testing. Similar to the previous step, check for continuity between the same test points. PCM connector B, pins 31 and 40. If continuity is present at this junction, it indicates a short circuit exists somewhere in the wiring harness, leading to these throttle position sensors, necessitating repairs to isolate and fix it. Conversely, if no continuity is found, the wiring may be intact, suggesting that the throttle body itself has malfunctioned, warranting its replacement as the next step to resolve the issue. After performing the necessary repairs and rectifications related to DTC P2135, it is essential to conduct a thorough final verification. This involves taking the vehicle for a test drive to observe if performance has returned to normal and if any symptoms have been resolved. During this drive, pay attention to engine responsiveness, acceleration, and any warning indicators on the dashboard. After driving, utilize the HDS again to check if the DTCs have cleared successfully and verify that no new trouble codes have appeared. A successful outcome would indicate that the fault has been effectively resolved and the vehicle is operating within its intended parameters. It may also help in identifying any underlying issues that may need attention. Engaging in preventive maintenance can significantly reduce the risk of encountering DTC P2135 and related issues in the future. Regular inspections of the throttle body and associated wiring are recommended to identify any wear or damage before they lead to failures. Keeping the throttle body clean is crucial, as contaminants can impair its functioning and lead to inaccurate sensor readings. Additionally, ensure that connectors are securely fastened and not exposed to moisture or dirt, which can cause corrosion over time. Regular diagnostics performed on the vehicle can also detect intermittent issues earlier, leading to more straightforward, less costly repairs. By following these maintenance guidelines, drivers can enhance the longevity and reliability of their Honda Pilot. In conclusion, understanding DTC P2135 is vital for maintaining the health of the Honda Pilot from 2016 to 2022. This code signifies an incorrect voltage correlation between the throttle position sensors, which are critical for engine performance. Through systematic troubleshooting steps, including verification, continuity testing, and identifying wiring issues, mechanics can accurately locate and resolve the problems. The importance of preventive maintenance cannot be stressed enough, as keeping the throttle body and sensors in prime condition can avert potential failures. A proactive approach not only saves time and money, but also ensures a safer driving experience. Regular diagnostics and timely interventions are key to achieving optimal engine functionality in Honda vehicles. Please like and subscribe to the channel. See you next time.